Hello, we are back on this webinar series. I'm happy to have you here with me. And today we're going to talk All right. So I'm Itamar. I'm an OpenSearch Ambassador. I'm the CTO and founder of Big Data Boutique. We'll talk about me in just a minute. But before that, the reason why we're here today is because we want to make sure that our searches work. What do I mean by that? If you will Google for a small lion, and you would have gotten something like this. So you Google small lion, you got this image, which obviously is not a small lion. Then you would probably not go back to use the search engine. We want to make sure that whatever search application you're writing, whatever search application you're using, whether it's an e-commerce website, whether it's an internal knowledge base, whether it's some catalog search like a real estate website or anything of that sort, always gets back really good results, and people can actually use it and go back to using it. So what you actually get when you search Google now is this, which is a small lion, right? So it's semantically, this is a better result. The reason why you get this is because effectively we are going to do some sort of a semantic search, some search that is not just keyword search, and that's what we will be covering today. So my name is Itamar. I'm sometimes I feel like I've been defined by being just a father for 4 girls, and just a girl dad. But most of them at my other time, I'm leading Big Data Boutique, which is an Elasticsearch and OpenSearch consultancy agency with really world-class experts on search and on operations for those technologies, and so on. I've been doing this myself for over 15 years in the search space and Elasticsearch and OpenSearch, and before that with Lucene and some Solar as well. And I'm an OpenSearch Ambassador as of September last year. And this is a great honor, and effectively, this is what we've been doing for a long time now, and that tells the whole story. Myself and a couple of my team are the maintainers for the OpenSearch Kubernetes operator, and we are about to release the version 3.0 for anyone running on Kubernetes. Watch out this space and the community spaces of OpenSearch. And we also created a platform called Pulse, which helps you maintain and optimize your clusters and basically forget that they are there and just enjoy stability and performance 24/7. Big Data Boutique, we are an AWS partner. We are prominently OpenSearch partners with AWS. We do a lot of OpenSearch work, but we also do consultancy for customers running OpenSearch self-managed on many other clouds as well as other big data open source technologies like Spark, ClickHouse, Kafka, Flink, Trino, and a couple more. So we can help with all of those, but a lot of our work goes to OpenSearch and Elasticsearch, and we also see a lot of search projects, and that's what we're going to talk about here today. So our agenda for today is to get to know OpenSearch just a little bit by just very high-level overview of what it is. I'm assuming you are actually familiar with OpenSearch. And then discussing the issues with keyword search, following to the potential solutions to those issues, right? So vector search and then semantic search using vector search and hybrid search. We'll discuss what it is, why it is needed, and then jump straight into I would say, the more advanced or more interesting stuff, which is query intent understanding and how to actually understand what someone searches for, and then measuring search relevance and tuning that further. So to start with, why OpenSearch? I would assume all of you understand and have seen OpenSearch before. Maybe you are already users of OpenSearch, but for those who don't, OpenSearch is effectively a technology that was released as Elasticsearch about 15 years ago. And then OpenSearch was forked out of Elasticsearch about 4 years ago in version 7.10 due to some licensing changes. And OpenSearch is being kept as 100% open source under the Apache Software license and under the provision of the OpenSearch Foundation, which is under the Linux Foundation, and it's being maintained by that body. And then also has maintainers from companies like obviously AWS, and then Uber and IBM and many others. So there's a lot of contributions coming from tech giants, as well as many other small companies like Big Data Boutique and others. And it's basically been maintained by the community at this point, with obviously big stakeholders that really care about the project and put a lot back into it. The reason why we see OpenSearch as a strong contender or a strong choice for anything semantic search and modern search in general, and AI-ready search, if you will, is because it's a very, very well understood technology. It is working really well. It's highly performant. It has been proven at scale. There is a rich ecosystem around it. There is companies to provide support and consulting, like Big Data Boutique and like the product that we have released, Pulse. And then effectively, you cannot go wrong with that. It's not like you're going with some vector database that was built by very smart people, but was built just a few years back. OpenSearch is pretty much a de facto standard when it comes to vector search and semantic search and AI and agentic ready search. There are managed options like Amazon OpenSearch Service, even Instacluster, and a few others. So you can also go and use that. And I've attached the link here. We'll provide the links at the end of the session in the YouTube video comments or description with this link. And effectively, this link is really a great entry point for everything modern search, if you will. So basically, semantic search and vector search, all topics we're going to talk about today. We won't have time to cover everything in depth, and that's a good place to start with when you go for look for good documentation. So when you do search today, and that's what I started with, small iron and so on, you will be effectively quite fast, follow some guide or blog or something, and you will get to implement a keyword search. Keyword search means you're going to take the text that the user inputted as a query, and then from that, you'll just execute the search on the data that you have, on the text that you have indexed. And the inverted index in Elasticsearch, OpenSearch will effectively do the heavy lifting for you. It is fast. You can get results on millions and billions of documents within milliseconds. It's definitely fast. There are some concerns that you would need to take care of, like normalization. For example, in English, that would be lowercasing and removing non-ASCII characters. So a lot of very standard normalization procedures. Everything is built into OpenSearch, obviously. And then also language-specific things like stemming, because tables and a table is basically the same word. You actually want to find them as if it was one, and then you will apply stemming. Other languages would have more sophisticated, we call those analyzers and stemmers, so more sophisticated algorithms to apply on them. And that would basically require some more, you need to apply some smarter techniques over there. And then the ranking, the way that we call it, so the scoring, the way that we put documents one above the other and try to provide you the most relevant results is often called TF-IDF, and the actual algorithm that's being used today is BM25, which is pretty much the industry standard for textual relevance ranking. And it's all really well known. There's tons of guides out there, and it's working really well. And again, it's very fast. However, today it's pretty much falling short in a lot of ways. To start with, it's not providing any semantic meaning, any support for semantic meaning. So if you would look for a crown, you'd find documents that talk about a crown. But if you are British and you are referring by crown, you refer to the king or the queen, that would not pop up, because a crown is a crown. It's not. It's the actual word. It's not anything with a meaning or a semantic relation to the word that you've been searching. And effectively, that is also why keyword search is good up to a point. For many years, we were solving this by applying synonym lists, which the veterans here would definitely know what it is and know the pains around it, maintaining it and removing false positives and so on. It's not really the way to go. The way to go is to somehow apply some semantic meaning or understanding to the query. And that is what we are going to talk about today, how to actually do that in 2026. Other issues include scoring. For example, again, the semantic meaning is not is going to change the way that things are going to get scored, and also how you measure that, and then precision and recall, which we're going to talk about in a bit as well. But bottom line is, the AI workloads that we have today are really not going to use keyword search properly. Any system that is a search system is going to be built and rely completely on keyword search and without any semantic meaning is going to fail miserably when you come to AI agents, because effectively, when you ask an AI agent something, it's going to make up its own words to search for whatever it needs to search. So it will understand what you're asking. It will generate some keywords to search for. It's not necessarily going to be the keywords that appear in the document. And therefore, we need to also support semantic search for that. And this is the main reason why I want to talk about this today. And I think there is a lot of really innovation, really things that you can go and do right now even. So starting simple by just talking about semantic search. Semantic search really is the way or the method of taking the query, passing it through some model, an embedding model of some sort, and basically moving the text of the query into something that is not text, and you are actually going to be able to search on Elasticsearch or OpenSearch in our case, and be able to get results back. Now, that embedding is, there are a couple of models out there. We really like Cohere Embed, for example. There's Titan, there's others as well. And those models are going to basically encode the text into vectors. And those vectors, your OpenSearch effectively supports searching using algorithms for vector search. Vector search, it's sort of an index. It doesn't really work like a standard index. The best way to think about it is a vector represents a word in the space. The embedding model is going to basically take the word and place it semantically close to other words. This is the embedding model's work. This is really what its purpose is to do and how it's trained. Different models will create different batches or clusters, the way that we call it. And then, we're talking about crown. So a crown would be next to a king, next to a queen, castle, things that relate to semantically to that concept. And foods will be next to foods, fruits next to fruits, animals, pets, and so on. And that's how basically when you search for a word, that word is going to appear next to other words that are semantically close to it. When a user searches for a word or multiple words even, we will produce a vector, and that vector is going to be, we're going to look for vectors that are similar, are close to the vector that we are searching for. Those vectors are the documents that we look for, and the closest vectors to the vector that we're searching for are going to be semantically close to what we're searching. So I'm oversimplifying a little bit. You're actually not going to use one vector per document. For real documents, you'll be doing chunking strategies. So you'll have multiple chunks and vectors that represent a single document. Each chunk will definitely have different semantic meaning because it's just part of the document. Products in an e-commerce website will probably have just one vector, because it's not a lot of text, and so on. But if you just ignore this oversimplification, the idea is that you, instead of searching for a word, you're now searching in a vector space, and that vector space will represent the semantic meaning or the what you're actually looking for. And it actually works, and that's the beauty of it. It's not really new. It's been there for a while. We were using a lot of sparse vectors before, and slowly we started using dense vectors, and then the LLMs just made dense vectors very, very accessible for pretty much everyone. So sparse vectors are vectors that can capture semantic meanings, but are not really producing very close batches. They are sparse in their nature, and usually will basically predefine some attributes of the document, of the entity that we want to index or to store. And those attributes, each document or each entity will receive some number or just even a Boolean value for each of those vector coordinates. And each position will represent one of those attributes, and that will be your vector. So very simple vector in that sense. It can be huge, it can be small. Often we see very small sparse vectors, but then they're also very cheap to compute. So it's not something that would cost you a lot to compute and store. And then when you search on it, it will work. The really capture semantic meanings, the LLMs really changed the word around that. And now you're able to execute a call to an LLM and ask it. So there's LLMs that are dedicated to producing vectors, embedding models, and then they will produce a vector for you that is dense. So it's actually it allows you to capture a really stronger, much better semantic meaning of any text, essentially. It is costlier to generate, and obviously slower as well a little bit, but it does capture semantic meaning very well. So you would need to decide which one to go with, but if you really need to capture strong semantic meanings, you would have to do embedding models that are based on LLMs. We've actually created quite a few products that run in production for customers using that. One really great example is an image search that we created for a customer, and effectively the user would search something like a sentence or a couple of words, will pass it through some embedding model, and then that embedding model will generate a vector, and that vector is going to be indexed when we index, and then on the search we'll basically do this vector lookup algorithm. KNN, the K nearest neighbors, this is usually the algorithm for small scale data sets. Let's say below 1 million vectors, it's definitely something you can do, and it will work relatively fast depending, of course, on the vector dimension and available hardware and so on, but it does work pretty fast. For anything above that, we're discussing ANN, which is approximate nearest neighbors. It is, again, well understood, well studied algorithms, usually HNSW, and then it will still work fast, although the number of vectors is huge. And it will be able to find, in this case, an image that represents whatever the user typed, or at least close to it. Whatever they tapped, whatever is in the picture, it will actually be able to kind of understand what you're searching for, and that's why it's so great. Again, there's a link here to our blog with the actual explanation and example. I encourage you to check it out. The reason why it's so interesting and so important is because we see a lot of RAG use cases today. So RAG, retrieval augmented generation, which basically means somebody asks a question, you like a chat in the chatbot, you go and retrieve the documents that are relevant to whatever the user asked, and then produce the answer back. And like I said when we just started, when somebody writes something in a chatbot, they're not going to use the actual words that will exist in document. Those are going to be words that basically describe what are the documents that you need to go and fetch. So you will need to understand the query, you need to generate the keywords to search, and you need to make sure that the documents that you're going to retrieve, even if they don't contain those exact words, if they're semantically close, you're still going to pull them out. And that's really why we want to use vector search and semantic search and so on, because for the AI agent, when agents decide what to search, you have zero control over the keywords that are going to be searched, and also refinement of the query, which something we would have based on for years. We'd say, okay, when the user searches for something, he doesn't find it, they'll probably refine. And then, for example, that's how we found synonyms in production systems for many years. But that's not the case today. You cannot really do that. And that's why we need vectors and we need semantic search. The problem with that is that semantic search is often not enough, because if someone searches for something and they actually search for, I don't know, a name of a person, and the LLM and the embedding model is actually not familiar with the person name, you're going to get really skewed or really bad results. And that's why semantic search on its own is not enough. That's one. The second one is the precision and recall element of it. For those not familiar with the concept, I took a picture from Wikipedia, and I think it summarizes it really well. But the idea is that you need to optimize precision on one hand, so making sure that the results that you do bring back, the top 10 results, actually represent the results, the documents that you were looking to find. They are in high relevance to the document, to the query that you submitted. And then there's also this concept of recall. Recall is those documents that are very relevant to what you've been searching for, but those that did not come up in the search. And we don't want to have bad recall. So we don't want to have really good documents not being pulled out. So precision is the concept of making sure that if you use the specific keyword, let's say a person name, that document with the actual person name does appear in the top 10. That's one, because you use the specific keyword, and you want to make sure that the top 10 or top 5 documents really address what you've been searching for. But then you also need the semantic meaning to still be considered, and typos, for example, and things like that. So you still want to be able to pull documents, even if the actual word did not appear exactly as is, and that's recall. And we want to improve recall. So semantic search helps us to get recall better a lot of times, but sometimes it hurts precision. Or if we kind of in the precision discussion, we also include the order of the results, the rankings, that also becomes interesting, right? Because how would I know if this first result is actually the best result, or how can I make it to be that way? And that's why we need to talk about hybrid search. And hybrid search is basically the concept of doing both, right? So executing semantic search with vectors and so on, obviously making sure that we use the right embedding model, that we use the right dimension for the vector. We do everything right there, but then also still using keyword search. And keyword search means just submitting the actual query, maybe with some amendments or optimizations, and I'll talk about a few just in a bit. But then still giving it a chance to boost some documents higher if they exactly catch the exact meaning of the thing that you wanted to find. So doing hybrid search right means doing keyword search right, and also doing vector search right, and then combining them together, often with something that's called RRF. So it's just it's just an algorithm that combines them, not using scores, but the actual rankings. By the way, sometimes performing this with more than just two lists, one keyword search, one vector search, sometimes multiple vector search, multiple keyword search queries that are built differently to kind of balance this out and then find really the best candidate. Obviously, it slows down searches sometimes, but if relevance is important to you, that's what you would be doing. And then basically, this is really the way to get things right. And again, I'll double down on that in just a bit. I do want to kind of highlight that there is a difference between hybrid search, which is what we just discussed, to just doing semantic search with metadata filtering, right? So you can filter always by labels, category, location, things like that, and do this kind of a very tough filter, not anything with has to do with scores. It's something completely different. I'm going to talk about something that we can do with that in just a bit, but hybrid search is not just doing semantic search with some filters. It's actually semantic search, vector search with the actual keywords that appeared in the query, but actually executed as just full text search, just like you would have done in any other case. One other thing that I do have to, when we talk about relevance ranking and precision and recalls and so on, we do need to remember that sometimes the business has some ideas about what is a good document and what is not. So, for example, in a news website, you should probably consider recent articles, recent news items as more important, right? So you would basically need to apply some decay function on the timestamp and kind of prioritize something for the last hours, last days, versus something from 5 years ago. So that's one. Internal knowledge bases would probably prefer something, again, with some recency, but also with, I don't know, more likes or something like that, right? On an e-commerce, you would probably want to prioritize things that are bestsellers. There is some risk of bias, obviously, but every business has its own notion of how to rank products higher in some cases. We call this, again, business signals and boosting. There is negative boosting and decay functions and obviously positive boosting. And that's something that you have to consider. And that goes on top or a multiply of the actual score and the actual rank that is being provided. And that brings us, and I'll go back to scoring and rankings in just a bit, but there's something that I do want to also go into, and that's query intent. So effectively, when someone searches for something like a cheap laptop, there is huge value if you actually can understand that, because when someone searches for cheap laptop is a word that exists as a keyword, basically. So if you search just as a keyword search, you will actually get results back. Maybe there's some semantic meaning. So instead of laptop, you would find something like, I don't know, computer or something like that. There's tons of examples like that. But the thing is that this word cheap would not appear anywhere in the result set. It's not something that someone would actually write. Your search engine that you're implementing would have to understand that when you search for cheap, maybe you're searching for, again, like that's written here, like budget computers, or just applying some, I don't know, business rules, for example, to boost negative boost, so basically reverse boost on price. So laptops that cost a lot or more than others are not going to appear at the top, right? So some semantic meaning. So you need to understand, there's some intent understanding. You need to understand the query intent, and that's really an art. This is really where things are going to go really well for e-commerce, for knowledge bases, and all of those. And that is done in several ways. It was pretty hard to get right a few years back. I think now it's very easy to get right, and even not too costly. So the way that we often do this is with just keyword extraction or intent extraction using LLMs or SLMs, if you will. So LLM models that are able to run fast and are not too costly. There's quite a few of them out there. We really like Amazon Nova Pro. It's a really great model. The new version of it really provides great results, and it's really fast, and it's also cheap. You can go on Nova Lite even in some cases. And the idea is to write a prompt that will really understand what you want to get from it. So it's really good at, for example, extracting entities, extracting names of people, doing a lot of things like that. And we do have an example that we've done not long ago, but basically on a shoe store or a clothing shop, right? So if you are already in the category of shoes, if we'll be searching for dinner, it will actually understand what would be the type of shoe to pick up for you. So again, there is a link here to an explanation of what we did, but basically the idea is that we just wrote a prompt that basically tells it you are an analyst or you are a shopper. Give me the synonyms or the words that relate to what I'm doing here, and just search for them as well. And that basically provides us with synonym expansion on the query side. And then we go with good old synonym queries and search for those specific shoes. So I don't know if what my users typed here would have converted or translated correctly on the semantic layer using vectors. Maybe yes, maybe not. I didn't take my chances. I just got that through some LLM, even the simplest one, and it was able to capture the meaning for me or expand the synonyms for me, and just plain old keyword search in that sense. So it's really strong method. We actually see this very strong method applied quite a lot in e-commerce and retail, and it provides tons of value because then you're able to filter or boost on categories, right? So if someone searches for like the prime example a lot of times is the red dress example. So if you'll be searching for a red dress, we're able to understand that the color, which is an attribute that we know of, it needs to be red. So we just filter on red. We don't boost or anything. We just filter on red. And then we either search dress on the semantic and keyword search, so the hybrid search on dress, or again, we can filter on a category, on a product type or something like that. And again, very easy to get done. I mean, the concept is easy. Getting this fully right will take some work, but eventually it's just prompt and context engineering. And with a good appropriate LLM, so not LLMs are the same. Some are better in some for some use cases and for some verticals. And then basically taking the query and basically extracting labels or categories or attributes, and then using that to construct your query. I would not take the LLM and tell it to construct an OpenSearch query. I would just tell it to extract based on, so for example, this red dress, this is the input. I don't know what the input is. I'm not doing any pre-processing. I'm just telling the LLM, understand what this is. And then those are the attributes that I have available. Let me know which ones I need to filter on, what is the value for filtering, and what are the words that I need to just run as is, right? So it would basically it would respond with color red, and then dress as a word that I need to run. Again, very powerful method. There is a lot of different usages for it, and we are actually in the this place of time, this era, that this is actually viable. You can actually do it and do it pretty well. If you have any questions, write it down in the chat. I'll be opening up for Q&A in just a bit, and happy to answer any questions that you might have. Just a few more items which I'll just skim through before ending the session, and I think are important. One is search relevance evaluation. There's no way of you knowing if you're doing things right or not, unless you are evaluating, or unless you are keeping an eye out for various metrics around your search engine. So are queries return with 0 results? Are there queries that are being abandoned without any clicks? And are the first click or second click the user is going to spend some time on? Tons of those, right? And then also you want to do some sort of synthetic measurements. So basically creating a judgment list. And once you have a good, strong baseline of search, so you created something, you are manually testing it, you're happy with what you're seeing, you call it a baseline, and then you create some judgment list. There's multiple ways of doing that. Some are curated, some are generated, and so on. And then you are going to basically try to improve your query versus the baseline, based on that judgment list. So it does take a lot of manual work. Back in the day, it was tons of manual work. Now you can automate some of it, obviously, but you still need to make sure that it's solid, it works well. And then there's a couple of metrics that you'll be checking out. NDCG at 10 is probably the most common metric to look at, but different use cases, different verticals will actually have different kinds of metrics that you would want to try and use. So it's a whole word on its own. It's a whole session just to be delivered on that. So I'm just putting it out there, but definitely if you go deep here, you definitely want to make sure that something is keeping an eye out for search relevance, for relevant results on your searches. Well, within OpenSearch, there is the relevance benchmark workbench, and you can definitely use it, and you should use it for running those benchmarks. There's other ways of doing that. There's libraries that or tooling that exists specifically for evaluation and so on. Some can be used also for obviously evaluating search results like DSPY and others. OpenSearch has built-in, very friendly, easy to use benchmark workbench for search relevance, and you should definitely take advantage of it. One other item, and just almost before we close, is the re-ranking. Re-ranking is your way of basically applying some of what we just discussed, and for various reasons, try to do something in a very crude way. So just keyword search and semantic with sparse vectors. So something that would get you good enough results, and only apply AI one way or another. There's various ways of doing that. For it can be an LLM, it can be a model like XGBoost and others, to basically push up documents or results based on various metrics. So it could be click streams, it could be likes, it could be business metrics, it could be whatever. And in some cases, you'd prefer to re-rank. So you would, instead of doing everything we just discussed to get the top 10 results, and those top 10 are pretty much good, sometimes it's easier or more economic to get the top 50 or top 100 and then pass them through a model that is continuously being improved. And that model, which is costed to run on everything, but for the top 50 or top 100, it's actually more economic, and then it will give you a much better result. So it's another method that exists. Learning to rank is one of those methods. There's also risk scoring API in OpenSearch and others. There's multiple ways of doing that, but it's definitely a method that's worth considering as well. Again, a whole topic on its own, but definitely something to keep an eye out. Last but not least is the discussion about scale. Most of use cases now are already above the 1 million vectors case. So we actually see quite a lot of them. We have handled hundreds of millions and even billion vector scale already, but it's not that common. It's not something you'd find all the time. I do expect that to change within 26, 27, as people are vectors become much more accessible, sometimes cheaper to produce and use, and then also the methods of maintaining them and making good performance. For example, OpenSearch now has the ability of computing vectors, so creating embeddings on indexing using GPUs, and Amazon Web Service exposes that through some API. So it's definitely something that's worth keeping an eye out for. And we did write a blog, and you have a link here to our blog, where we actually discussed the methods and how to actually look at scaling vector search based on the size that you have. We'll publish another one that is specific to OpenSearch soon as well, and there's lots of other good content over there. So just to summarize everything, and again, I'm going to open up for questions soon. If there's any questions, I'll be looking at that in a second. Keyword search is really, of something of an older era. It's not something you should really be doing today on alone. It's easy enough to get started with semantic. And semantic search, vector search is pretty much easy to get right. even cheap if you're going to go or with dense vectors, and it's definitely something. Sparse vectors. It's definitely something you should pay attention to and actually start doing today. Whatever you're doing, just make sure you also check out relevance, and you keep a really close eye on relevance. And I believe that query intent, which seems to be a little bit on the edge, right? So it's basically not something everyone is doing, but it's not that hard to get right. And I think it's something that you should definitely look into. Sometimes with good query intent searches, you can it can sometimes perform and provide more value even than semantic search, because it will actually focus whatever you need to get done. Maybe you still need some semantic layer to improve your recall, but other than that, it's really something you should take into consideration. That's all I have for today. Definitely check out the blog. I'll be basically opening for questions. I don't see that I have any. Maybe I'll wait for a few more minutes to see if there are some questions. And otherwise, I'll be closing up. Okay. Okay, seems like everybody's overwhelmed, I guess. Thank you so much for attending this. And for those of you watching not live, feel free to reach out to us. We'll be happy to assist you with anything OpenSearch, AI, Gen AI, and big data related. And yeah, have a great time.